Hello class, this is our last lesson for the week. We are going to cover exercise 7a. Yes, we jump all over the textbook for this topic. Please copy the heading Exploring Parabolas into your workbooks. Equations that have rules with x squared in them are quadratics. For example, y equals x squared, that's a quadratic. Y equals x squared plus 5x plus 6. That's a quadratic. And their graphs are parabolas. Now, parabolas look like this and like this. These are some examples of parabolas in real life. We can see like this bridge, this roller coaster, this basketball. All of these things are examples of parabolas. This here is our basic parabola. Its equation is y equals x squared. Other parabolas are kind of variations of this basic parabola. There are certain key features of parabolas that you need to be able to identify. This here, this line down the middle of the graph, is called the axis of symmetry. The point where the parabola crosses the y-axis, so over here, it's called the y-intercept. And these are the x-intercepts. So you'll notice this parabola has 2. And this point down the bottom here, it's called our turning point. The turning point is where the graph changes direction. So if we look at the graph on the left, this is our basic parabola, y equals x squared. Its turning point is here. This is where the graph changes direction. It's going down and then it goes up. We call this type of turning point a minimum. It's the minimum point of the graph, or the lowest point. This one on the right, this parabola has the equation y equals negative x squared. So it's flipped upside down. So its turning point, where it changes direction, is up here. What do you think we call this turning point? We call it the maximum. It's the maximum point, or the highest point, the parabola reaches. Let's have a go at identifying the features of this graph. So the axis of symmetry, that's this line through the middle of the graph. So the axis of symmetry is at the point where x is negative 3. Then we're asked for the type of turning point. So my turning point is up here. And the type of turning point is a maximum because it's the maximum point of the graph. Next, we're asked for the coordinates of the turning point. So I look at my turning point and then read the coordinates. Remember, coordinates are written x and then y. So the coordinates are negative 3, 5. Our x-intercepts, they're these two parts here. So we've got x-intercept at negative 5 and another x-intercept at negative 1. And lastly, we're asked for the y-intercept, which is all the way down here, that the graph crosses the y-axis. So that's at negative 5. All right, let's identify the features of this parabola. So the axis of symmetry, that's the line through the middle. And I can see that that's at the point x equals 1. I'm reading that just off the coordinate from the turning point. The type of turning point. So the turning point's down here. it's at the lowest point or the minimum. The coordinates of the turning point, they're written there already for us. 1, -4. The x-intercepts, here and here, -1 and 3. And then the y-intercept here, -3. Last one. So axis of symmetry, that's this line down here. So the line is at x equals -2. Our type of turning point, so our turning point is up here. So it's a maximum. Coordinates of the turning point. Okay, so it goes x and then y. So my x coordinate is at -2 and the y is 0. Our x-intercepts, well, this is actually also our x-intercept there. There's just one of them this time, and that's at the point -2. And then our y-intercept down here at -4. That's all we will do for today. I don't want to overwhelm you. So could you please complete the building understanding questions from exercise 7A and question 1 from the main exercise. If you have time remaining at the end of this period, could you please catch up on Monday and Tuesday's work so that it can be submitted to me ASAP?